Loki, log aggregation inspired by Prometheus. Agenda, log indexing approaches. Loki history, why Loki, query lifecycle, getting started, basic workflow, streams and labels. Log aggregation. Log aggregation collects log output from every service and server into one place, so a team can search across all of them at once. If an incident spans multiple services, aggregated logs let you follow a request trail without opening dozens of separate files. Almost every team running distributed systems eventually needs some way to centralize and search logs at scale. Any team already using Prometheus for Matrix benefits from a logging system that fits the same operational model. Indexing every word of every log line becomes expensive fast once log volume grows large enough. Full text indexing and label indexing. Full text indexing analyzes and indexes every word inside every log line, enabling rich search but at real storage and compute cost. Loki instead indexes only a small set of labels attached to each log stream, leaving the log content itself compressed and unindexed. Full text indexing, Elasticsearch, ELK, EFK, every word indexed, higher storage cost. Label indexing, Loki, only labels indexed, inspired by Prometheus. Problems with full text indexing at scale. Single point of cost, indexing every word of every log line multiplies storage requirements many times over. Index size grows continuously with log volume, straining both disk space and memory. Running a full text search cluster demands significant operational expertise to keep healthy. Two separate systems and mental models are often needed, one for metrics, another for logs. High cardinality full text indexes can slow ingestion under heavy log volume, misses out on a simpler, cheaper approach when most searches really just filter by a few known labels. The Loki system, Promtail or another agent, tails log files and shifts them to Loki, attaching a small set of labels to each stream. Loki indexes only those labels, storing the actual log content compressed in cheap object storage. Grafana queries Loki with logql, filtering by labels first before searching within the matching log content. Other similar or related logging systems, Elasticsearch, the ELK stack, EFK stack, Splunk, Grafana Tempo, Traces, same family. Loki advantages, dramatically lower storage cost than full text indexing since only labels are indexed. Uses the same label model as Prometheus, so metrics and logs share one mental model. Scales cost effectively by storing log content in cheap object storage like S3. LogQL, log query language, feels familiar to anyone who already knows PromQL, Prometheus query language, PromQL. Integrates natively with Grafana, sitting alongside metrics dashboards in the same UI, backed by Grafana Labs and a growing open source community. Everything is a label, almost. One huge benefit is that in Loki, almost every log stream is identified by its label, not by indexing its content. The same label set that identifies a Prometheus metric can identify a Logi log stream, like app equals checkout, EN equals production. Narrowing down logs starts with labels, then filters within that already small set of streams. Because indexing is so lightweight, ingesting huge volumes of logs remain cheap and fast. This label first philosophy is the direct reason Loki is often described as Prometheus but for logs. Streams and log QL. Stream. All log lines sharing an identical set of labels. Log QL filters by labels first, then searches within matching content. Promtail config YAML file. Promtail tails log files and attaches labels before shipping them to Loki. A log QL query. A log QL query filters by label, then by content, and computes a rate over time. History. Developed by Grafana Labs and first announced in 2018, drawing direct inspiration from Prometheus design. Built specifically to avoid the cost and complexity of full text indexing every log line. Designed from the outset to integrate tightly with Grafana as its native query and visualization layer. Adopted the label model almost unchanged from Prometheus, letting the same mental model span both metrics and logs. Now a core part of the open source Grafana observability stack alongside Grafana and Tempo. Why Loki? Cost efficient. Indexing only labels keeps storage and ingestion costs low. Familiar? The same label model and query style as Prometheus and PromQL. Scalable. Cheap object storage handles log content at very large volumes. Integrated. A first-class citizen inside Grafana dashboards and alerting. Simple operationally. A smaller index means fewer moving parts to keep healthy. Backed by Grafana Labs and an active open source community. The chunk store. Loki stores compressed log content in chunks, separate from the lightweight label index. Chunks are typically written to cheap object storage like S3 or GCS rather than local disk. The index only ever needs to point at which chunks match a given label set. Never expect Loki to full text search arbitrary content as fast as Elasticsearch. Its speed comes from label filtering first. Loki query lifecycle. Promptail tells logs, ship, attach labels, label, chunks in storage, store, log QL in Grafana, query. Logs are shipped by an agent, tagged with labels, stored as compressed chunks in object storage, and finally queried with log QL through Grafana. Getting started with Loki. This leads us to the three steps that get logs flowing into Loki. Run Loki. Start the Loki server to receive and store log streams. Configure Promptil. Point an agent at your application's log files. Query in Grafana. Add Loki as a data source and run your first logql query. Basic workflow. Shipping, labeling, and querying. Some call ship, label, and query Loki's everyday loop. Label should stay low cardinality. Filtering happens on them first before any content search. LogQL's content filters run only within the streams a label query already narrowed down. Dashboards can mix Loki log panels right alongside Prometheus metrics panels. Alerting rules can fire based on log patterns, the same way they do on metrics. Supports many workflows, incident response, debugging, security monitoring. Works the same whether logs come from Kubernetes pods, VMs, or serverless functions. Any questions? Thank you.